And here's the idea. So to show you the algebraic definition, I grabbed an example from a previous lesson. And now let's just go about by calculating the probability of boots given girls. So here we're given girls. So I'm going to create a little subset here. I'm going to circle girls here. So my sample space is 116. It's no longer 192. And then out of these 116, I want to see how many of them preferred boots. And if I look, I can see that it's these 35 people that decided to get boots, or 35 girls that decided to get boots. So my probability here would be 35 out of 116. So I'm going to keep the ratio right now. I'm not going to give you the percentage because I want to introduce the algebraic formula to this. So we're going to leave this to the side for a bit. And now I want you to I want you guys to think about these probabilities. The probability of boots and girls, and the probability of girls. Okay, so now let's say we were just trying to look for these probabilities. The probability of boots and girls, well, we kind of already did that here. Boots and girls, that's going to be 35. But since we don't have a condition, the sample space is going to be 192. Now let's get the probability of girls. So to get the probability of girls, we look at girls and we look all the way to the right. Our total is 116. And again, since we don't have a condition, the given condition, the sample space is going to be 192. So now comes the punchline. Let's consider this calculation, the probability of boots and girls, and let's divide that by the probability of girls. So here we get a 35 over 192, and we're going to divide that by a 116 over a 192. And we reviewed how to calculate our ratios being divided by one another. We're going to use that procedure, if you want to call it that, keep, switch, flip. So let's keep the numerator 35 over 192, and then we're going to multiply it by, well, we're going to switch division to multiplication and then divide by the flipped version of the denominator. We're going to flip the denominator here to get 192 over 116. Now here I'm going to use a math trick. So when we're multiplying fractions and it turns out that you have something similar on the top and something similar on the bottom, you can actually cancel those out. So we can cancel the 192 and the 192 there. So we get a total of 35. So these ones just become ones. So 35 times 1 is 35, and then 1 times 116 is 116. And after looking at this for maybe 2 or 3 seconds, you should realize that 35 over 116 is exactly the same probability we calculated when we had a certain condition. So probability of boots in the girls was equal to 35 over 116, but at the same time, the probability of boots and girls being divided by the probability of girls gave us the same result. So using discoveries and patterns, I claim that the probability of boots and girls, probability of boots given girls is equal to the probability of boots and girls being divided by the probability of girls. Okay, so they're both going to give you the same ratio. If they ask you to calculate the probability of boots given girls, you can do so by calculating the probability of boots and girls and dividing it by the probability of girls. And this is a sketch of how the formula can get derived. But yes, this is just a demonstration. And if you do this for a billion different problems, you're always going to get the same thing, that the probability of A given B is equal to the probability of A and B over the probability of B. So let's generalize this. Let's put this on our notes. Well, hopefully you're writing this down on your notes as well. But here, let's give you the good stuff here. So here's the algebraic definition of conditional probability. The probability of B given A is equal to the probability of A and B all over the probability of A. If you look at some textbooks, this can also be written as probability of A given B equal to the probability of A and B all over the probability of B. So they're both correct, but this one tends to make more sense. I actually learned it like this, so this is how I memorized it, but this is actually better. So anyways, let's apply it and let's do some examples.